My name is Ann-Vanessa and my project is on an electronics retail store management system. This presentation consists of case study and functionalities, ER diagram, logical table derivation, SQL data types and constraints, indexes and queries. CompuGhana is one of the fastest growing IT businesses in Ghana. It is primarily focused on offering all IT-related products, solutions, home appliances, mobile devices, and electronic devices. A robust corporate staff at the company oversees managing all activities linked to purchases and after-sales concerns for our corporate and government clients. My project is aimed at creating an online database system to make keeping track of company details easier and more convenient after the COVID-19 era. My ER diagram consists of supplier, product, customer, loyalty, service, staff, branch type, department, and a generalization specialization of the staff. From the diagram, we see that supplier supplies a product, customer purchases products, customers subscribe to loyalties, the staff provides a service serves a customer, staff belongs to a branch has a branch type, staff belongs to a department, and there's a mandatory or relationship between the staff and the specialized entities. A logical table consists of an entity with its primary and foreign keys and all other non-key attributes. For example, we see that supplier has supplier ID as a primary key and foreign keys, supplier name, supplier location, and date of partnership. We also see that loyalty has a primary key, loyalty ID, and non-key attributes, date of subscription, and loyalty type. The same goes for the service table, which has a primary key, service ID, a non-key attribute, service name, time of start, time of end, and service description. We see that customer has a primary key, customer ID, and foreign keys, loyalty ID and service ID. Loyalty ID and service ID are primary keys of the loyalty and service tables respectively. These tables are the parent tables of customer, hence their primary keys are posted in the customer table as foreign keys. The product table also has a primary key, product ID, and foreign keys, supplier ID and customer ID. Supplier ID and customer ID are both primary keys of the customer and supplier table respectively. The customer and supplier table are both parents of the product table, and hence their primary keys will be posted in the product table as foreign keys. I also created a table called purchases, which represents the relationship between the customer and the product, because it was a one-to-many relationship, with the many side having an optional participation. We see that the primary key of purchases is product ID, which is the primary key of products, which is the parent table of purchases. The foreign key of purchases is customer ID, which is the primary key of the customer table, which is the child of product. The table with mandatory participation becomes the parent, and the table with optional participation becomes the child. The primary key of the parent entity is posted as a primary key in the relationship entity, and the primary key of the child entity is posted in the relationship entity as a foreign key. I created a normalized table branch type, which consists of type ID, type name, and type description. I created this table to reduce redundancy in the branch table. The primary key of branch type becomes a foreign key of the branch table. I also created a generalized table staff and specialized tables from the staff table, which are full-time staff, part-time staff, and intern. Staff ID and staff, which is the primary key, becomes the primary and foreign key in the specialized tables. The data types I used were int, tinyInt, date, char, and varchar. I used int to store integers, tinyInt to store a smaller range of integers, date to store the year, month, and date, char to store a single character, and varchar to store a range of characters. The constraints I used were not null, primary key, foreign key, on delete cascade, and on update cascade. I used not null to ensure that the record is never a null value, primary key to enforce uniqueness by not accepting duplicate values, and to ensure no null values are accepted. I used foreign key to provide a link between data in two tables. On delete cascade to ensure that a record deleted in the parent table will be deleted in the child tables. And on update cascade to ensure that a record updated in a parent table will be updated in the child tables. In SQL, an index is used to retrieve data from a database very fast. Indexing is the way to get an unordered table into an order that would maximize the query's efficiency while searching. I created the indexes based on queries that were used in the project and were simply created to make the queries run faster. The first index I created was index purchase, which was created to enable finding the purchase information of a customer easier and faster. The next query was index department, which I created to help find department information easily. The next index I created was index service, which was used in finding the service performed by each department and staff member. The last index was index supplier, which I created to help find the supplier and any products the supplier had supplied. A query is a question or inquiry about a set of data, and SQL is used to retrieve meaningful and relevant information from databases. The queries I created were in accordance with my functionalities for the electronics retail store management system, which are to keep track of yearly and monthly purchases, to keep track of maximum purchases made by a customer based on the purchase price and the number of purchases made, to qualify the customer for a loyalty card, to keep track of the number of staff that performed a particular service, to keep track of purchases made in a particular month, to keep track of products supplied by each supplier, and to keep track of departments with less than 3 staff members. Departments with less than 3 staff members would mean that the department is understaffed. I created the first query to keep track of the number of staff that performed a particular service. The second query was created to keep track of the number of purchases made a year. The third query was to keep track of departments with less than 3 staff members, to know if the department is understaffed or not. The fourth query was created to keep track of the maximum purchase made by a customer based on the purchase price and the number of purchases made. This was to qualify the customer for a loyalty card. The fifth query was created to keep track of purchases made given a particular month. So with this query, we see that the month selected is February, which is represented by 2. The last query was created to keep track of products supplied by each supplier, given the supplier name, supplier ID, and the product name. In the next slide, I will be doing a short demo of the queries and their results. Thank you for listening to my presentation.